Hello, I'm Alex from the Mozaic Works studio, and today what I want to show you is a codecast of refactoring C++ code, legacy C++ code, by using the method that we've discussed in previous installments of this series. A method that takes the existing code, first turns it into pure functions, and then from there we move to a new version of object-oriented code, if we want to. Before we move on, I'd like to show you the code that we will be working on. This is a code base created specifically for practicing legacy code techniques. It's called Trivia. It's a very short, fairly short code base. It just has a few hundreds lines of code, but it's very interesting because it's made on purpose to be much more complicated than it needs to be. So what we have here is, first of all, let's look at, there's a class called GameRunner that has the main function, creates a game, adds a few players, uses a random thing here to roll, and then it goes into a loop as long as there's no winner. And I also wrote a few tests that these tests are in the idea of golden master tests. So basically I ran all of the tests once, saved the results. You can see the results here. Out golden master. And now whenever I need to, I can rerun the tests. They will create a new set of files, and I can compare these files with the initial ones. This is a very simple technique to help me ensure at the end, in this case, that the code still works. So that would be the short introduction. We can now move into actually starting the refactoring of this code. First of all, I did a few slight changes on the initial code base because there are some things in there put on purpose to annoy the compiler, and I already solved those. We will focus now on refactoring this code through pure functions. So what do we want to do? The fundamental idea here is to select, to pick any part of this code base, extract it into a function, and then try to make that function pure by going through a few steps. In case you don't know, a pure function is a function that returns the same outputs for the same input values. So it's basically like a huge table of inputs, output. And these types of functions are very interesting because they are much easier to test. All you need in order to test them is data-driven, so a table of inputs and outputs to test a lot of variations of the function. In order to get to these pure functions, we extract the code, we try to make it static, we will see what the compiler tells us, and we try to weed out the dependencies little by little, and you'll see the technique in action. It's much easier to do than to explain. For a while the code might look a bit worse than in the beginning, but we'll see that this is simply an intermediate step, and we will take this dive into making the code potentially worse for small periods of time. Okay, so let's see first what can we do. We can extract, as I say, any part of the code. Let's extract this. Do something, I don't know exactly what it does. Right, I can go here. And now what I'd like to do is, first we want to make everything immutable. So in order to get to a pure function, we need to have two things. One, the values that they are received are not mutated. It doesn't use any variable from the context, so from the class and so on, and then it returns the same values for the same inputs. So let's see. We want to make this a constant. Seems that we can. What happens if you try to do this static? It tells us that there are a few dependencies here. We see here there's another function called create_row_question. So let's remove this for now because we want this to compile. This is an interesting function. It can be static. Moreover, let's say if we change the signature to make this const, it can be const. There's no problem here. So now we have a function that's static and const. What I'd like to do with it is to extract it from the context of this class. And in order to do so, I will write a lambda. And I would love to have something that allows me to extract a lambda, a kind of refactoring that allows me to extract a lambda from a method, but as you can see, there isn't one. So in order to do so, I did a little trick of myself. I'm gonna copy this, gonna select this part, and then I'm gonna do an active template, use a lambda, use the same names, and this returns a string. Remove these two lines, and now we have a lambda. And now what I'd like to do is to replace this whole thing with return this of index. Remove this. Let's see if it compiles. It does. Let's see for the sake of it if it still runs. Yeah, it does. And now what I can do is to inline this. But first of all, because this is a lambda, I will need to move it higher up. Okay. What have I done with you? Ah, okay. My mistake. So create row question lambda. Let's see where this is used. It's used here. We can inline this. And now we get a weird refactoring. I can inline this here. Now that's interesting. So I got one lambda out of it. So what is interesting about this function is that it doesn't depend on the current class anymore. It's a free function, and we can move it anywhere we want. And we can also apply lambda operations on it, which means that we can bind variables, we can pass it as a function parameter, we can do functional composition if we want to. Well, let's do the same for the other functions here, because we see there seems to be a pattern, right? Is in place back instead of pushback. Interesting. I won't deal with this yet. We will at some point. Okay, so what we'd like to do is to extract this first. This would be sports question. I'd rather do it as a string. Right, this should still work. So as you can see, I'm not running the tests, and this is on purpose because I believe this method, when you do it mechanically and properly, you don't actually need to write tests on the existing code. You can make these small steps, very safe refactorings, to get you to the point where you have pure functions and only at that point write tests. But we'll see how this works. So let's extract this. Let's call it create sports question. Seems to be about right. Okay. Create sports question. It's already const. Now, it's good that it's const in the sense that I know I'm not changing anything. But what I'd actually like would be to turn it into a static, and it cannot be both static and const. Create sports question. Cool. So it can be static. That's great news. If it's static and it receives const parameters, it's very likely, and we can read it here, but it's very likely that it doesn't change anything from the context. It doesn't change its own parameters, so we can deal with it. Let's do again the same trick. I want to turn this into a lambda. Select this, lambda, create sports question, goes const int I, returns a string, remove this line, remove this line, replace this, I, auto format, move this up, see where it's used, inline, deal with this weirdness, inline, inline, and now we can see a pattern growing here. Let's see the next thing. make trivia. Okay, seems to run. Probably a good idea to commit from time to time. I'm gonna create a new try. Let's say a new branch. Extract lambdas for create questions. Cool. We have this, so now let's apply the same. Actually, before we apply the same pattern, we can look at this function. I don't care too much about it at this point. But in this case, we could probably return str1 directly, and it will still work. So simplify create. Which one was it? Sports question. Cool. Next one would be, so we still need to look at something. Let's extract, no, we want to extract this. Place this occurrence, this is a science question. And once again, let's make it a string. Now let's use the constructor. Let's extract this, create science question. Going here. It's const now, which is great news, but let's make it static because I don't want to use anything from it. And yeah, it tells me it can be made static now. This means we can apply exactly the same thing as until now. Oh, remove this, replace here. Still need to be careful when you're making these changes. Move this up. Inline. Deal with the weirdness. Inline in reverse order, so it should be science question. And then this. Now we have this. Let's look at create science question for a minute. See if we can change things from it. Yeah, I think we can return str directly. Let's write. So now I'm not trying to test the application. I'm just making sure that nothing obvious is broken, basically. Extract lambda for create science question. Cool. Next one would be do something. Oh, I think it was pop question, right? Oh no, it was science question. That's good. Let's do something with this now. Pop question. This defines a whole weirdness. It should be a string. Extract this as a function. go here. Once again, it does a weirdness. And return this directly. It's const, gray news, remove constness, be static, perfect. Once again, extract the lambda. Remove this line, remove this line. Auto format. Type of question lambda y. Move it up. Inline. Deal with this weirdness. Inline in reverse order. And we have a do something function that's better. And now create pop question. Now there is some duplication between these 4 lambdas, but we don't care about that so much. We'll just make sure that things are rolling forward. So I'd like to inline this back for now. Now we could replace this with transform in C++ or map in all the other functional or programming languages that have functional features. But I don't really find it necessary at this point. We might come back and do something about it at a later time. So that's it for now. We managed to get to a nice place with this, and let's look a bit of these lambdas. These are extremely simple functions, and they are very simple because 1, they are short, but 2, they have no side effects. They are outside the context. They are free functions. I can move them anywhere I want. This also means that I can group them together if I want to into a class that maybe creates questions, right? And this is the power of this technique. I can take these things and extract them through mechanical steps. Now I can write tests on these using data-driven tests or property-based tests. And then I can also regroup them into classes and just inject the classes here. This is the power of this technique. I find it extremely useful. So thank you for now. This is part 1 of this codecast. We'll see in the next parts what will happen. Until then, don't forget to think, design, and work smart.